Exponential functions, vertical shifts, stretches, and reflections. Like other functions, we can transform exponential functions and see how the transformations appear in their graphs and equations. The general form of exponential functions is f of x is equal to a times b to the x plus k. The three parts of the equation affect the transformations that we can see in the graph. So first, we're going to talk about A right here. When that is always the vertical stretch or compression, and it can also be the reflection. When A is, so we're here first talking about reflections, when A is greater than 0, the graphs will look like one of the two graphs in example 1. So it'll either look like this, that will be one way that that graph might look, or it can look like that if it's greater than 0. When A is less than 0, the graph will either look like this or like that, one of those two. This is a reflection. It's a reflection across an axis, a horizontal axis. It's a reflection across a horizontal axis. And if we haven't moved this graph up or down, it's a reflection across the y-axis, which is horizontal. That's not horizontal. It's a reflection across the x-axis, which is horizontal. All right, so when A is between, we're looking ahead, the graph is compressed by a factor of A. So when A is between -1 and +1, so A is greater than -1 and A is less than +1, with A not equal to 0, A can't equal 0, the graph is compressed by a factor of A. So it's squished. It's vertically compressed. When A is less than -1 or A is greater than +1, the graph is stretched vertically by a factor of A. All right, now we're looking at B. B is the base or multiplier. Now K. K is the vertical translation or shift. The asymptote will always be y is equal to k. So there's that horizontal line in all exponential functions where the graph is getting close to it, closer, but never quite gets there, or it could be going this way as well. But it's always horizontal. So now let's look at this function, and we're going to graph that. Now, when we have a k value that's not equal to 0, it's easiest if we think of the rest of the graph without thinking of k at first. So the first thing I'm going to see is that when k is 0, then that a value there is my y-intercept. So -1/2 would be the y-intercept. And then the b value there, in this case 3, is the multiplier. So when we move to the right 1 unit from the y-intercept, we multiply this y value by the b value there. So -1/2 times 3 would be -1.5. And then when we move to the right from there, we take this y value, -1.5, and when we move to the right one, we multiply it by 3, so it's going to be -4.5. And as we move to the left, because we're this way, we're multiplying by 3. This way, we're dividing by 3. So we're going to be getting really close to the x-axis really quickly there. And so our graph is going to look like that. Now, that is what the graph looks like if B is 0. But in this case, B is not 0. B is 4. So what we do then is we take our asymptote, which was at 0 when B is 0, and the asymptote now moves up to y is equal to 4. So I'm going to draw my asymptote in there as a dotted line to show it's not part of the graph. And then I'm going to move my whole graph basically moves up 4 units. So since my y-intercept here is negative 3.5 or negative 0.5, I go up 4 units. 1, 2, 3, 4, and it's right there. All right. So my actual graph is going to be right there. That's going to be 1 point. Now up 4 units, 1, 2, 3, 4, right there at 2.5. Y is 2.5. Here we were at negative 4.5. 1, 2, 3, 4. So right there at negative 0.5. And so we can graph like this. And we'll just get close to this horizontal asymptote like that. And now we should erase our original working here. And so that's the easiest way to graph these kinds of things. So when we are looking at writing a function that matches the graph, we're going to work backward, and we're going to first start off with our k value. So we look at this and we see that our horizontal asymptote right here is at negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So our k value is negative 9. So I'm going to put in a little dotted line there at the horizontal asymptote. And so k is going to be, minus 9. And now I think, okay, well, what if I moved that horizontal asymptote? What if it was up here at y equals 0? Then this point would be 1, 2, 3, 4 units above it. So 1, 2, 3, 4. So the y value would be at 4. So my a value then is going to be at 4. So because we move up 9 units, we can say, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that is a y value of 4. So our a value then is 4. And then our multiplier, well, if we went up 9 units, then we would have this one right here. And if we went up 9 units, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be there at a y value of 8. So if this is negative 1, 8, and this is 0, 4, then we can see that we're dividing our y value by 2. That means that our b value has to be 1/2. So our b value then is 1/2, and it's raised to the x power. So working backwards there is pretty important. When you're given the graph, you start with the k value, and when you are given the equation, you ignore the k value. And that is vertical shifts, stretches, and reflections in exponential functions.